and this is my next video. Today I am going to explain Leetcode question number 1572 matrix diagonal sum. Given a square matrix mat, return the sum of the matrix diagonals. Only it should include the sum of all the elements in the primary diagonal and all the elements in the secondary diagonal that are not the part of the primary diagonal. What they given question? They given on square matrix. Okay, we need to return the sum of the matrix diagonals. We should include only the sum of the primary diagonals and secondary diagonals, and if the second diagonal element is repeating, that we need to exclude. In the input, what they given? They given 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a 3 cross 3 matrix. It is an odd matrix. If it is an odd matrix, means we will add primary diagonal and secondary diagonal. Afterwards, we will subtract which element is repeating. That element will subtract. Okay. In example 2, it is an even matrix. We will not subtract anything, just we will add the primary diagonal and secondary diagonal. What element is coming, that we are printing. In the example 3, mat is 5. There is only one number, that is we are printing. We can understand briefly in the whiteboard. Okay. See, this is the example 1. I am adding the primary diagonal. Primary diagonal consists of 1, 5, 9. I am adding just. I am getting 9 plus 1, 10, 10 plus 5, 15. It is a primary diagonal. Secondary diagonal consists of 3 plus 5 plus 7. 3 plus 5 plus 7. Yes, 7 plus 3 is 10, 10 plus 5 is 15. I am getting total is 30. 15 plus 15. Okay. What I am doing, the secondary diagonal element is 5 is repeating from the primary diagonal. Already it is there. If you adding, again it is there. Just what we will do, we will do subtract 5. 30 minus 5 is 25. We are getting 25 our output. Where when our n is odd, only this will work. When n is 4, it is an even matrix. Okay, it is a 4 cross 4 matrix. Then what will happen? We will add all our primary diagonals and secondary diagonals. Primary diagonal consists of 1 plus 1 plus 1 plus 1. It is a primary diagonal. We are getting 4. 1 plus 1 plus 1 plus 1. This is a secondary diagonal. We are getting 4. Total 8. Just for printing. Now we can enter into the coding part. Here n represent the number of rows in the matrix. It is initialized with mat.size in the n variable. Okay. I taken some variable sum initialized with 0. I taken two nested for loops. Here outer for loop starts from variable I. It will start from 0 to the n elements it will traverse. Inner for loop I taken variable with j. It will start from 0 up to it will traverse n elements. Okay. I will check the condition. There are two conditions. If any one condition is satisfied, this will be executed. If I equals to j or I plus 1 j should be equals to n minus 1, then only it will execute. After completion of all the elements of traversing, finally we are returning the sum. Let's begin dry run with this example. Okay, this example consists of 4 cross 4 matrix. Our n value will be 4 here. Here n value will be 4. Sum will be initialized with 0. Starting. Your outer for loop will start from 0. It will traverse up to 4. J will start from 0. It will traverse up to 4. We can start to iterate now. When 0 is equals to 0, yeah, this condition is true. Then we will add. Our sum will become starting 0 plus mat 0, 0. Mat 0, 0, what is that? We can write indices 0, 1, 2, 3. This is 0, 1, 2, 3. 0, 0 is 1. Our sum value is 1. We can write here. Our sum starting will be 0. After it will be 1. Now our j value will be updated to 1. 0 is equals to 1. No. 0 plus 1 means 1. 1 is equals to n minus 1 means 3. Okay. No. 0 plus 2 is equals to 3. No. J value updated to 3. 0 is equals to 3. No. 0 plus 3 is equals to 3. Yeah. So our sum value will be updated now. It will be 1. We should check 0, 3. 0, 3 is 1. Our sum value will be 2. Now I value is 1, j value is set to 0. Okay. Now we will check the condition. 1 is equals to 0? No. 1 plus 0 is 1. 1 is equals to 3? No. Sum value is 2 only. Now j value updated to 1. 1 is equals to 1? Yes. Now sum value will be 2 plus, we will check 1, 1. 1, 1 is 1. 2 plus 1 is 3. We will update it 3. Now sum value. Now 1 is updated, j value updated to 2. Okay. We will check the condition now. 1 is equals to 2? No. 1 plus 2 is 1 plus 2 is 3. Where 3 is equals to 3? Yes. Now our sum value will be 3 plus, we'll check 1, 2. 1 with column 1 is 2 is 1. 3 plus 1, 4. Sum value is 4. Now j value updated to 3. We'll check now. 1 is equals to 3? No. 1 plus 3 is 4. 4 equals to 3? No. Now I is updated to 2. J will set to 0. We'll check the condition. 2 is equals to 0? No. 2 plus 0 is 2. 2 is equals to 3? No. Sum value is 4 only. Now j value updated to 1. 2 is equals to 1? No. 2 plus 1 is 3. 3 is equals to 3? Yes. Now sum value will be 4 plus is 2, 1. Row 2, column 1 will check. Yes, 1. 4 plus 1 is 5. Sum will be 5 now. Now j value updated 2. See, I is 2 and j is 2. This condition is 2. Now we will update. Sum value will be 5 plus we'll check 2, 2. Row 2, column 2 is 1. 5 plus 1 is 6. Now j is updated to 3. 0 is equals to 3. 2 is equals to 3. No. 2 plus 3 is 5. 5 is equals to 3. No. Sum is not updated. Now I value is 3 and j value is set to 0. 3 is equals to 0. No. 3 plus 0 is 3. 3 is equals to 3. Yes. Now sum value will be 6 plus 3, 0. 3 row, 0th column is 1. 6 plus 1 is 7. Now j is updated to 1. 3 is equals to 1. No. 3 plus 1 is 4. 4 is equals to 3. No. Now j is updated to 2. See here. 3 is equals to 2. No. 3 plus 2 is 5. 5 is equals to 3. No. Now j is updated to 3. Yeah, 3 is equals to 3. This condition is true. Now sum is, yes, sum is equals to 7 plus 3 with 3. Third row, third column is 1. Our sum value will be 8. Finally, we are returning our sum as 8. Okay. This is by using brute force approach. We return the logic. In this logic, the time complexity is taking big of n square and space complexity is taking big of 1. Why time complexity is taking big of n square means we are using your nested for loop to traverse the entire matrix. Here the outer for loop will runs n times and inner for loop also runs n times. So it takes time of big of n cross n, where nothing but it is n square. When come to the space complexity is taking big of 1 because we are using only the single variable sum. We are storing the result. No extra space we are using. So it is taking space of big of 1. Next we can write the logic for optimized code. Okay. Yeah, this is optimized solution compared to the previous solution. Okay. What I done here, I taken n variable n. It will represent the number of rows and columns in a matrix. After that, I taken one variable sum, initialize it to 0. I started to iterate the for loop. It will start from 0. It will travel up to the n elements. Okay. The sum variable will be store the number of primary diagonals and second diagonal elements. Okay. For each iteration of the loop, the element of mat I plus mat I minus 1 will be added to the sum. Here, mat I will represent the primary diagonal and mat I minus I will represent the element of secondary diagonal. Whenever after completion of entire for loop, I will check the condition. If n is odd means then it will work. Then this statement will be executed. If n is even means it will not execute, it will skip and it will directly will return the sum. Okay. How it is going to work? We can dry run, then we will come to understand. See here n is 3. If it is a 3 cross 3 matrix. Okay. Sum value will be initialized to 0. When I will be 0, no? Then what I will happen? Sum will be sum plus mat of I means it's a primary diagonal, the second diagonal. It will be 0, 0. We will check 0. First we can write indices 0, 1, 2, 0, 1, 2. See 0, 0 means this 1. Mat of I means 0. I will write n means here 3. Okay. 3 minus 0 is 3. 3 minus 1 is 2. 0, 2 I will check. 0, 2 is 3. Sum value will be 0 starting plus 1 plus 3. our sum value will be 4. Okay. Now, when our I value is updated to 1, then sum will be 4 plus, we will check now. I value will be 1. 1 means this 1, 1. Okay. 1, 1 means what? 5. Okay. This is 1. I will check. N is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1, 1, 1. 1, 1 is 5. Okay. I get 5 plus 5, 10. 10 plus 4, 14. Now I value will be updated to 2. When I value will be 2, now I value will be 2. Now mat 2, 2. Mat 2, 2 means what? 9. Okay. Now this sum value will be 14. This sum 14 plus 2, 2 is 9 plus now mat of 2 will check. N is 3. 3 minus 2 is 1. 1 minus 1 is 0. Now mat 2, 0 is 7. 14 plus 7 is 21. 21 plus 9 is 30. Our getting sum is 30. Okay. Now we can check the condition. Now all elements are iterated. Okay. See, because now our I value will be 3. 3 is less than 3. This condition is false. We'll come out of this for loop. Now we'll check the condition. Okay. Now see, what is n? Our n is 3 because it is an odd matrix. If it is 3 means this condition will be executed because 3% is 2 is equals to 1. Yeah. Now what we'll do? We will do sum equals to sum minus mat of n by 2, n by 2. Means sum here we got 30. Mat of n by 2, n by 2 is central element 5. Okay. We will get mat of 1, 1. 30 minus mat of 1 means 5. We will get 25. Doubt. Now I'll go with second example. Here where n is 4 because it is a 4 cross 4 matrix. Starting sum value will be 0. I will start from 0. When I value will be 0, the sum value will be 0 plus 0. I value is 0 means 0, 0. This value will be 0. N value is 4. 4 minus 0 is 4. 4 minus 1 is 3. We will check this. 0, 0 means what? 1. Okay, 1. 0, 3 is also 1. We are adding 1. We are getting sum value is 2. Okay. Now sum value will be 2 plus. Now I value will be updated to 1. Mat 1, 1. Mat 1. 4 minus 1 is 3. 3 minus 1 is 2. Now see. Now 1, 1. First, second row, first column is 1. First row with second column. We are getting 4. Now our I value is updated to 2. This will be 2, 2 and 2. 4 minus 2 is 2. 2 minus 1 is 1. Now sum value will be 4 plus 2, 2 means second row, second column is 1. Now 2, 1 means second row, first column is 1. I will get 6. Now I value will be updated to 3. Now mat 3, 3, 3. 4 minus 3 is 1. 1 minus 1 is 0. Now sum value will be 6 plus mat 3, 3 means third row, third column is 1. 3, 0 means third row, first, zeroth column 1. I'm getting 8. Now I is updated to 4. Because 4 is less than 4 means this condition become false. We will come up with this for loop. Now we are checking the condition. Where here n is 4. This condition will not execute for even matrix. So we are writing sum. Our sum is 8. Next, we can understand the time complexity and the space complexity of this logic. The time complexity is taking big of n, where here n is the number of element of the matrix. We are iterating all the elements once. So the space complexity is taking big of 1 because we are not taking any extra space. We are taking only constant amount of space. Okay. Thank you guys for watching my video.